Hello, good morning all. In this video session we will see the numerical method, that is Dunkerleys method. Dunkerleys method, it is a numerical method to find the natural frequency of the system for the beams problem. It is a approximate method. In this method we are considering the deflection of all the points to find the natural frequency of the system, and the deflections it is converted as the frequency of the point. Okay, see here we are using this formula where Fn it is the natural frequency of the system and Fn1 it is the natural frequency of the system due to load 1. Similarly, it is the natural frequency of the system due to load 2, natural frequency of the system due to load 3, and natural frequency of the system due to nth load. In the figure you can see it is a simply supported beam which is subjected to 3-point loads and as well as UDL, where W1, W2, W3 are the loads, and this is the UDL of intensity m kg per unit length, and Fn it is the natural frequency of the system subjected to all the loads, that is point loads and UDL, and Fn1 it is the natural frequency of the system due to this load alone. Fn2 it is the natural frequency of the system due to load 2. Fn3 it is the natural frequency of the system due to load 3. Fns it is the natural frequency of the system due to UDL alone, and delta 1 it is the deflection due to W1, delta 2 is the deflection due to W2, and delta 3 it is the deflection due to W3, and delta S is the deflection due to UDL. And to find the natural frequency we are using 0.4985 divided by square root of delta 1, where delta 1 it is the deflection due to load 1 alone, and we are using the same equation to find the natural frequency of the system for other points also, where delta is the deflection. Okay, to find the natural frequency you are using the deflections, and to find the natural frequency when it is subjected to UDL we are using 0.5615 divided by square root of delta S, where it is the deflection due to UDL. This is the Dunkerleys equations. Substituting in this equations all these values, we get this thing. Okay, so this is the equation to find the natural frequency of the system for the beams problem. Okay, 0.4985 divided by square root of delta 1 plus delta 2 plus n number of deflections at the beams, and this delta S divided by 1.27 it is for the UDL. When there is no UDL present, then you ignore this value. Okay, let us go to problem. Okay, in this problem it is asked to find the natural frequency of the system by Dunkerleys method. E value is given, Young's modulus, and I value, moment of inertia, and we already know how to find the influence coefficient for the beams. Okay, it is a to find A11 we are using A cube divided by 3EI, where A is the distance of the mass 1 from the fixed end. Similarly, to find A22 we are using this distance 300. Okay, 300 divided by EI. Okay, to find the deflections, it is required to find the deflections to find the natural frequency of the system. Now in this problem there are two masses, so we need to find the deflection at point 1, deflection at the mass 2, that is delta 1, delta 2. So we are using Fn divided by Fn equal to 0.4985 divided by square root of delta 1 plus delta 2, only delta 1 plus delta 2, because there are two masses. These loads are, okay, you find A11 and A22. Okay, when A11 is multiplied by this force, okay, where M1 is 100 kg, convert it to force 100 into 9.81, when it is multiplied by A11 it gives deflections delta 1 Okay, similarly this is mass into 9.81, it gives force. F is equal to m2 into g. Okay, when it is multiplied by A22, okay, then when it is multiplied by A22, it gives us delta 2. Okay, m2g, it is the force. If it is multiplied by L cube by 3ei, L cube by 3i, it is the influence coefficient, that is A22. Okay, substituting delta 1 and delta 2, that is the deflection at mass 1 and deflection at mass 2. Okay, you will get the natural frequency of the system. Okay, now we will go to some one more problem. It is a simply supported beam. A shaft diameter is 50 mm. The length of the shaft is 3 meter, and it carries 3 weights: 1000 Newton, 1500 Newton, 750 Newton. And these loads are at a distance 1 meter, 2 meter, and 2.5 meter from the left support. Okay, Young's modulus is given here. You need to find the frequency of the transfer vibrations. As in this problem there are 3 loads, we need to find delta 1, delta 2, and delta 3. How to find delta 1? Delta 1, this weight multiplied by influence coefficient A11, it gives us delta 1. 1000 Newton into A11, it gives us delta 1. Similarly, this weight into A22, it gives us delta 2, and 750 into A33, that is the influence coefficient, it gives us delta 3. Okay, substituting the value in this equation, it gives us natural frequency of the system 1 by 2 pi square root of g divided by delta 1 plus delta 2 delta 3. Why 3 deflections? Deflection of the mass 1, mass 2, and mass 3. Okay, how to find delta 1? A11 into weight of this weight 1000 Newton. Okay, how to find A11? You already know in the previous videos how to find the influence coefficient. You just refer that video. How to find A11? L1 square L2 square divided by 3EIL. What is L1 here? L1, it is the distance of this mass from the left support. L2 is the distance of this mass with respect to right support. So L1 is 1 meter, L2 is 2 meters divided by 3EIL, okay, this is A11. When it is multiplied by weight, this is 1000 Newton, we get delta 1. Similarly, find delta 2, delta 3, substitute in this equation, you will get the natural frequency of the system. Okay, this is also same method, same problem. It has also 3 loads. To find the natural frequency, you find delta 1, delta 2, and delta 3. How to find delta 1? This weight into A11. Okay, similarly, to find the delta 2, this weight into A22. Okay, similarly, to find A33, this load into A33. Okay, then there is in this problem, it is as the shaft weight is considered. The shaft weight, it is 1900 Newton per meter length. Okay, it is distributed throughout the length of the shaft, so it is assumed as the UDL. Okay, what is the intensity? 1900 Newton per meter. Okay, to find the deflection due to weight, the weight is uniformly distributed throughout the length, so you find a delta S, one more deflection due to UDL, 5 divided by 384, WL raised to 4 divided by EI, where W, it is the intensity of loading, that is 1900 Newton per meter. Okay, now you consider all these deflections, that is deflection due to load 1, load 2, load 3, and deflection due to weight, that is UDL. Okay, when UDL is present or uniformly distributed load is present, you have to consider delta S divided by 1.27. Okay, this is how you find a natural frequency of the system when it is subjected to loads as well as